My name is Alireza and I'm a third-year PhD student working on 3D content protection. But what is 3D content protection, or more specifically about my topic, what is 3D content encryption? The main aim of my research is to provide usable encryption primitives for 3D applications in a way that it maintains the usability of objects for the applications. For example, the current state-of-art encryption algorithms are not capable of maintaining the size and boundary of 3D objects. And therefore, if you render encrypted 3D objects, it might not be usable for different applications. So one of the most important requirements in 3D security is to maintain the boundaries and the size and dimension of the encrypted content. To give you an example, let's consider this virtual environment that contains maybe thousands of 3D objects, right? And there is one object that contains privacy-sensitive information. Let's say, for example, the silver man, and we want to encrypt it. So we can encrypt it using any state-of-art methods. But the problem is that if we encrypt it, for example, using AES, the outcome would be something like, so you can see that the encrypted outcome of the silver man actually covers other objects. So we don't want such a thing happen. We want to maintain the usability of the virtual reality. So we are looking for solutions like in a way that if we render the encrypted content, it is still within a bounding volume, such that it guarantees that the object doesn't overlap or crash into other objects. Any object is defined within a bounding volume. For example, if you look at this figure in here, we've got a statue of a lady and she's actually defined within a sphere. So my aim is to encrypt this object in a way that the encryption object is still bounded within the same bounding volume. The main reason for this is that because in animations we are trying to avoid collision between different objects, and it's actually, if you consider bounding volume, it's much easier for the machine to recognize the dimensions of the object. It's much faster for it. So it is. So I try to use the same concept for the encryption of objects. For our group is mainly looking for doing fundamental research. We are looking to do good research, and this is the most important thing for us because we have long-term goals. We are looking for the technologies that's going to happen maybe in next 10 years, next 20 years. So we are going to do we want to create a new knowledge. We don't want to do something incremental. And actually, this is the main goal of our group here at Griffith University.